So we can do this translation any direction we want to. Okay, so let's go back to our checklist. We did how to do the translation, right? Similarly, you can do rotations. So what I'm going to do, I'm going to create another matrix just for rotation, right? So transformation, this was our translation. Now I want to set something for rotation, right? Okay, so I'm going to copy the exact thing and I'm going to comment this out. We don't need to print everything we are setting up. So instead of doing that, I'm going to make this a rotation matrix. So let's say rotate M, and then I need to set the rotation. So let's consult our class for the rotation. So for set rotate, we need the angle X, Y, Z. So I'm going to copy the whole thing here, and then let's copy and let's paste it here. We need to change the name. So this is still from the copy. So now I want to do the rotation. So I'm going to change this object. Okay, so I need to set the rotate. So this is the angle of rotation, right? And then we need to set which axis we are going to use for the rotation. So these are the tasks. So let's say we want to rotate alongside maybe z-axis or x-axis. Let's start with x-axis. So let's make this one 1, rest of them 0. And then let's use any random angle here. Let's set 1 first and see if we can rotate at least by 1 degree. If you want more documentation from this, you can see the angle of rotation need to be in degree. There can be confusion, like we have radians and degrees, which one it is going to be. And that is going to clarify your question here. Let's actually rotate this by 45 degrees and see what happens. So we have a rotation matrix, and now I need to pass that to the shader, right? So here we have this translate M. I'm going to use the same matrix for all the operations from now on. So let me change the name a bit to make it consistent with what we're doing. So in the book, I remember they were calling this xlet, right? X form, which was transformed. So let's call this X form, or let's call this transform. And this one. Then we have this uniform variable here. This is fine. We can rename that to transform and that to transform. And so we are still using the translate M, right? This is not changed. So this is still there. We are not using the rotate yet. So what is going to happen if I run this now? So if I run this now, translate M is not defined. We have that on 124. Oh yeah, I never defined. Go back and see 124. Okay, so still it's U transform, right? So I need to change this here. This is the location we're going to use. This can stay. Now this was as it was before, but we don't want to do the translation. We want to do the rotation. So I'm going to replace the translation matrix with the rotation matrix here, and see if we can rotate it around x-axis by 45 degrees. So you can see the rotation, right? Because it is rotating around x-axis, it is rotating from the screen. So you can see it looks slightly shorter because of the rotation. To understand better how the rotation is working, let's rotate it around the z-axis, which will make more sense. So this rotation is making more sense, right? So we are doing a 45 degree alongside along the z-axis here. But we can do multiple rotations. It is preferred to have rotation matrix setup done for all three axes differently, which you'll see later. But now you have the idea how to do the rotation. Okay, so next thing I'm going to do is I'm going to do a scaling. Okay, so copying the whole thing, and then let me call this scale M. Similarly, I'm creating a new matrix, and then this is the scaling matrix, and we are going to set scale. We can always check the documentation here, how they are doing that. So we have scale, we have set scale, and as I said, you can define which axis you are going to scale the object on. So if I want to scale, let's copy the whole thing. If I want to scale it, let's say along Y, how we are going to define that here. So if I don't want to change anything, I can make all of them 1. So multiplying something by 1 is not going to make any change. But what if I make the size double alongside, let's say, y-axis? So let's make this 2. And then I'm going to use this scaling matrix here. I think I copied the wrong thing. So here we go. So this is sort of obvious, right? So now we have the triangle doubled on length. What if I want to make it same? Let's make it 1.5 times longer, and maybe same for the x-axis as well. So now it is consistently larger than the original triangle, right? We can always make it smaller as well. Let's make it smaller, 0.75. or half maybe 0.5. So now the width is half of the original triangle. So this is more or less the idea how to apply these three transformations separately, as we mentioned in our concept. So the last thing I'm going to show for the transformation is how to apply all the transformations together using a single matrix. Before that, I'm going to give a quick 3 minutes break, and if there is any question. All right. If there is no question, then I'm going to start again at 12:10. All right. So let's continue with more transformation, how to combine all the transformations together in a single matrix and then apply that matrix to our object to maybe rotate or scale or translate it using the same matrix. Okay. So what we have now here, we have this translate, rotate, and scale, and we are just using the element from that matrix, passing that to the transformation matrix here in our shader. And the shader is doing the job of transforming the key vertices and render the whole object. For now, this is 2D, even though this is not actually 2D, this is 3D. So we can apply the same concept for a box or a block or a cube, right? But now I want to apply multiple, every time I want to do some transformation, I'm just using that matrix here. I want to have something that will combine the multiple matrices together. And how that can be done, right? Okay, so in order to do that, what I'm going to do, I'm going to create a new matrix that is called the, I'm going to call them the model matrix. So the model matrix is similar to this one. First, just an identity matrix, which I'm going to call model matrix. It's a very common name. You'll learn more about the concept in the lecture. And then if I print this, you'll see this is just 1, 1, 1, and similar to the one we saw before. But once I apply some transformation to it, it will be it will save the transformation in the matrix, right? So let's try that. So how do I apply? I just multiply the required transformation I want with this model matrix. How do I multiply? And again, our knowledge about this class is going to be handy. So we know we can do multiplication using some function here. So we have this transpose, inverse, concat, multiply, vector 3, all these things. But this multiply is used for multiplication of matrix 4 and matrix 4, right? And we're going to use this function. And I'm going to use this matrix. And then I'm going to call the multiply. In the multiply, I'm going to, let's use the translation first. So I'm multiplying the translate matrix here. Then I'm going to use this one here. Right? Okay, so let's see if this works or not. Technically, it should work without any problem, right? So now we have a similar translation here. But now you want to apply maybe, let's say, a scaling to this one. I want to make this, let's say, shorter. Shorter will make more sense. Or maybe shorter on height and maybe wider on width. So let's try to do that. I am going to use the same model matrix. So after the multiplication, now the model matrix already has the translation. So now if I apply, maybe let's do the scaling. Let's use the same scaling. So the height will be half, the width will be double. So multiply the scaling matrix with this. And now you see, we have a scaled version of the triangle, but still it is translated. So we applied multiple operation to the triangle, right? So at this point, I'm going to change this name of the matrix to model matrix because that is more like the traditional way of calling it, right? So you'll see in our book, they will call this a model matrix. If you go to the example, let me show you actually. Leah Matsuda. Oh, they're still calling it X-form matrix, but in the future chapters, I'm pretty sure they're, let's see. these are going to be more complex examples, but okay, so they have the view metrics. So at some point, they're going to introduce the model metrics, but I am not going to spend time looking for that. I'm just going to go ahead and rename this as model metrics, and then use this here. Eventually, for future works in C, you'll have view metrics and other objects here with camera and other definitions. But for now, the model metrics is going to do. So some more replacement here, here, and here. I'm just going to save the code and refresh to see everything is working fine. Okay, now. So now, if I want to apply multiple transformation, right? That's what I was doing. Okay, so what did we do so far? We did translate, we did scaling. Here is one important concept that you need to make sure that sequence of the applied transformation is right, because if the sequence is not correct, then you'll see there will be some problems, right? In the book, there is a section, I think, called translate first, then apply rotation or something. I believe. So no, you have to do the rotation first, then you have to do the translation, and then you have to do the scaling. So let's say if we want to apply the rotation here, then what are we going to do? So we are going to do another multiplication here. And let's use the same rotation, 45 degree alongside the axis, and see the results. So what are we expecting? So this should rotate by 45 degrees. Then there will be a translation. Then it will be scaled, and see if that is done properly, right? So this is what was happening before. So this is rotated, scaled, and then translated. But if we change the sequence, the scaling is not going to be a big deal, but these two, if we change the sequence, you'll see the results are going to be different, right? Because the multiplications, they are not exactly interchangeable for matrix multiplication, right? So if I do this, you can see the results are not exactly the same, even though we are using the same transformations. I didn't change any values, just I changed the sequence. So if I translate first, then rotate, then you see that. If I reverse that, then the result is going to be this, different. So you have to be careful when for the blocky 3D animals, how you are going to apply the rotations and the translation and the scaling. You'll learn more about that in the lecture. So I'll leave that for that. Maybe if there is a question, I can answer that.